Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is a lesson 5-5, solving irrational inequalities. So let's get right to it. Today we're going to solve polynomial inequalities, solve rational inequalities, and apply inequalities. Now, the rules are going to hold true for whether they're not polynomial or rational inequalities, but we're going to try and first, excuse me, make sure that the function is greater than or less than or equal to 0. And we're going to find all of the zeros of that expression once we've done that. We're going to find the places where the functions are undefined. We're going to use these values. The book calls them critical numbers from steps 1 and 2 to set up intervals. And then we're going to test points and intervals to see which intervals make the expression true. All right, so I've got 4 examples here. And so the first one here asks us to solve. And so the first thing I'm going to do here is to follow my rules. I'm going to make sure that the function is either greater than or less than or equal to 0. So we're going to try and get this to be less than or equal to 0. So here's what I'm going to do. I'm going to distribute. So I'm going to go 2x plus 7 is less than 3x minus 12. So I distribute. Oh, I didn't do it right. Distribute. All right. And then we're going to try and get x by itself. So I'm going to subtract 2x and add 12. And so if I subtract 2x from both sides, I'll have x on this side, and then I add 12 to it. I'm going to get, let's see here, 12, it will be 19. And so my solution is just x is greater than 19 if I flip the whole thing. Yeah, you could technically leave it like this. We usually do like an x is greater than as our final answer. Okay, and so it says find the values that satisfies the inequalities. So y equal to 2x minus 3 for y greater than or equal to 1 or y less than 0. So let's do the y less than 0 one first. So if I go 2x minus 3 is less than 0, then solve that for x. I'm going to add 3 to both sides, so 3x is less than 3, and then x will be less than 3 over 2, and that'll be that solution there. And if I go y is greater than or equal to 1, I'll go 2x minus 3 greater than or equal to 1. And again, same thing, we're going to add 3 to both sides, so I have 2x greater than or equal to 4, and then x greater than or equal to 2. That's my solution there. Okay, this one says find the solution to inequality, then use your graphing calculator to verify the solution. All right, so just like, so this is a quadratic. So remember, when we talk about quadratics, oops, I need my pen tool. When we talk about quadratics, we can have a graph that looks like that, or another graph where it looks like this. And so where it's less than a value, you could have either just a portion, or you could have 2 parts where it's either less than or greater than a value. It just depends on what the solution is going to look like. So again, I'm going to try and get it either less than or greater than 0. So in this particular instance, we're going to subtract 16 from both sides. And that'll give me x squared minus 6x, and then it'll be minus 7 less than 0. And we want this less than 0. And when we go to graph it, to verify, having it less than 0 gives us a nice, easy boundary to look at on the graphing calculator. So this thing I want to factor. And again, if it doesn't factor, you could use the quadratic formula on the left-hand side to get the zeros. And so this thing factors 2 factors of -7 that add up to -6, x minus 7, and then x plus 1. We want that to be less than 0. And so that looks good. And so what we're going to do is we're going to find those critical numbers. All right, so we're going to find the critical numbers here. And the critical numbers are where these two, what are these two are 0. So my critical numbers for this one is going to be x equals -1 and x equals 7. Okay, come on. Equals, I want 7 here. I don't know what happened with my thing, but we'll get through it. All right, and so I'm just going to make kind of a little number line here. I'm going to put -1 there, I'm going to put 7 there, and I'm going to test some points. So let's say I pick like -10. -10 is clearly in this interval over here. -10 makes that negative. -10 makes that negative. So negative times a negative is positive. And a positive number is not less than 0. So this interval does not count. When I pick 0, 0 is between -1 and 7. So 0 makes this negative, 0 makes that positive. Negative times a positive is a negative. And so any negative values are less than 0. So this interval will be part of our solution. Then if I pick like +10 makes this positive, +10 makes this positive. So this interval will have only positive values. So my solution is only the places on the x-axis where it's less than 0. That's where it's going to be negative. So my final answer is going to be, let's do interval notation. Will be 0, or excuse me, it'll be from -1 to 7. Or if I do inequality, it'll be -1 less than x less than 7. Now, if we grab our graphing calculator, we go to the y equals and we clear out that, and we go x squared minus 6x minus 7. And I know that this is an equality, but if we look at the graph here, we want to know where the function is less than 0. Well, it's less than 0 wherever the blue curve is below the x-axis, which is where y is equal to 0. And we can see that from -1 all the way down to +7, it is less than 0. And so we have correctly found the interval. All right, next one. It says, solve the rational inequality, then use a graphing calculator to verify the solution. Here, it is already less than or equal to, greater than or equal to, less than or greater than 0, and so we don't have to move anything. But because I have an expression like this, I'm going to say we want to make it easy on ourselves by making it a single fraction. All right, and so for me to do that, take my 1 over x minus 4. I need a common denominator, so I'm going to use funky 1, and I'm going to have that x over x. That'll give me a common denominator less than 0. So I'll have -4 or 1 minus 4x all over x, and we want to figure out where that's less than 0. So the critical numbers for a rational function are where the function is is 0 or undefined. Well, it's 0 when the numerator is equal to 0. All right, and so if I solve that, I subtract 1, I have -4x equals -1, that means x equals 1/4 when I divide. And it is undefined when x is equal to 0. All right, so when x is 0, this whole thing is undefined. I get 1/0, that's undefined. So this one has critical numbers at 0 and 1/4. Okay, so this one has, again, a number line. Have one at 0, and I'll have one at 1/4. All right, so again, I'm going to pick a value in this interval here, and so I'm just going to pick -10. -10 times -4 is +40, plus 1 is 41, over -10 is going, so positive divided by negative is going to be negative. And then from 0 to 1/4, well, that's not very easy. I'm just going to pick an eighth. So +1/8 times 4 is +1/2. 1 minus 1/2 is 1/2. 1/2 divided by an eighth is a 16th. Or is it 4? It doesn't matter. It's positive. All right. And then when I pick a number over here, say +10, 1 minus 40 is negative on the top, divided by +10 is positive on the bottom. Negative divided by positive is a negative. And since we're looking for where it's less than 0, our intervals would be from -infinity to 0, unioned with a quarter, not a half, Macaulay, a quarter to +infinity. Or if we wanted to do inequality, we could say that x is less than 0 or x is greater than 1/4. That is going to be my solution. Now, if I go to my graphing calculator, can't use the original in this case because, or no, I can't use the original in this case because it's just less than 0. But I'm just going to throw this out here. So go to a graphing calculator, go to my y equals, clear this, alpha, fraction 1 minus 4x all over x, like that, hit graph. And we want to know where it's less than 0. Well, we said from -infinity until we get to 0, it's less than 0. And then from 0 to a quarter, it's greater than 0. And then from 0 to +infinity, it's less than 0. And so clearly, we have gotten our interval correct in this particular instance. So that's all I got for today. Today's Marvel fun fact of the day is The Falcon and the Winter Soldier is not only the first MCU series on Disney+, but is also the first appearance of U.S. Agent, one of the number of characters that has replaced Steve Rogers as Captain America in the comics. That's all I got for today, folks. Have a good day. Bye.